Yo, Shriram. Yo, homie. How you doing, brother? How's your day so far? I'm just doing this guy. Okay. Yo, Idor, what's up? What's up? Okay, ready to grind, lads? Ready to grind? Howdy, Rover. Oh, driving home? Nice. Okay, so let's get started because again I have 45 minutes. We'll try to at least cover majority of this one. This is just for this week that I'm super busy. What's up, baddie? Who's bad? Me. Okay. So as you know, right, like I have a bunch of meeting. I just came out of a meeting, so that's why I'm late. I woke up at 6. It's 7:17 right now. And I have a meeting at 8 because of work. This is just one of those hard times going on in industry itself that I'm having issues and I have to attend so many meetings and stuff. Because I think if you are in the job market, you know things are hard right now with AI. But nevertheless, I'm still like as a promise, I will come even like if it is for 45 minutes, I will come and let's cover as much as we can for the networking concepts. And then in the evening again, we'll do our lead code. Okay. So let's get started with our journey. Let's put it this way. Close this guy. Networking concepts. Oh, need to share my screen. I forgot almost. Okay, howdy. Hope you guys can see the screen and everything. And you guys can hear me good, right? Yeah, networking. Let's go. This is like one of those topics without which you can't be a hacker. It's interesting to like it's very few topics are like so important that you can't be a hacker without them. So, this is the one introduction, task 1. Have you ever wondered why you need an IP address to access the internet? Is it true that an IP address can uniquely identify the user? Are you curious to learn what the life of a packet looks like? If the answer is yes, let's dive in. The first room is this room is the first room in a series of 4 rooms dedicated to introducing the user to vital networking concepts and the most common networking protocols. Networking concepts, this one. Then there is networking essentials, core protocols, and security protocols. So, room prerequisites. This room expects that you know the terms such as IP addresses. Hopefully, you guys know. TCP port number, I believe you guys know this too. However, we don't expect that the reader is able to explain such terms in proper technical depth. I think you guys can do that really well. We covered a lot. If you are unfamiliar with these terms, please consider joining pre-security path. Learning objectives, and let me paste this. One sec. So just in case if you guys want to follow. Okay. Learning objective. By the time you finish this room, you will have learned about the following: ISO OSI network model. This is actually an important one because it helps break down things very well. IP addresses, subnets is very big, and routing. Subnets is one of those concepts I know how to explain very well, so you won't have trouble. It's an interesting concept, and a lot of people don't understand it, which makes total sense. TCP, UDP, and port numbers. How to connect to an open TCP port from the command line. You get your notepad ready, let's begin. Yay, our first streak in a long time. Task 2, OSI model. Before we start, we should note that the OSI model might initially seem complicated. Don't worry if you encounter cryptic acronyms, as we provide examples of the OSI model layer. OSI model, if you I explained in simple terms, right? There is just how networking happens between two computers. It is given in terms of a model, like some layers. Okay, what all layers are, and that's what is called OSI model. Nothing big or crazy. It's just once you see it, you will understand, and I will explain everything very well. We assure you that by the time you finish this module, this task will feel like a piece of cake. The OSI, Open Systems Interconnection Model, don't worry about the big words, is a conceptual model developed by International Organization of Standards, Standardization, ISO, that describes how communication should occur in a computer network. In other words, the OSI model defines a framework for computer network communications. Although this model is theoretical, it is vital to learn and understand as it helps grasp networking concepts on a deeper level. The OSI model is composed of 7 layers. So, what they said is OSI model is basically the standard. The whole world uses it. Every single computer, cloud, everywhere it's used. It's a international standard. If you want to build a computer, or if you want to build a tech that can talk to another tech, right? You want to build a phone, want to build a server that can talk to other servers. You have to follow this model because this is like the language they speak. In the OSI model, there are 7 layers. This is from bottom, actually, I will say bottom up. So, physical layer, data link, network layer, transport layer, session layer, presentation layer, application layer. We'll see, don't worry. The number starts with the physical layer being layer 1, as you can see at the bottom. While the top layer, the application layer, is the layer 7. To help you remember the layers from bottom to top, you can use mnemonic such as please do not throw spinach pizza away. Actually, you won't even need this, honestly. Like once you do it couple of times, you won't need this mnemonics or whatever. You can check the internet for other easy to remember acronyms if this helps you memorize them. Remembering the OSI model layer with their layer numbers is important, otherwise you will struggle to understand terms such as layer 3 switch and layer 7 firewall. This is true. This is how it is used even in cloud. When I'm going to build basically load balancers, there is layer 4 load balancer, there is layer 7 load balancer, stuff like that. TCP/IP framework is modern world. Yeah. Like they both talk about the same thing. TCP/IP framework and OSI both talk about the same thing. It's just two layers are merged into one another. It's basically that, right? If you think about it, which is not wrong. Like they are not wrong. It's very easier. Makes it easy for people. Okay, going to layer 1. But that's actually a good one, I will say this. And let me copy image and put something here. Let me show you exactly what happens. So it's easy for you guys to understand what is going on. For people at least who don't know, right? Let's say this is your Google Chrome here. This is your Google Chrome or browser, whatever. Can I increase? So we have Google Chrome here, right? You want to send a Gmail message from your to another friend's system, right? Who is also using, let's say, Google Chrome or any other browser, let's say the best browser in the world right here, in my opinion, at least. Internet Explorer. The best in town, lads. The baddie, the real baddie. Okay. So how things work, right? Application layer is like a Gmail. It's your application which you interact with. Things go first top to bottom, then bottoms up. So we have application layer, which is your Gmail and whatever. And all these like add extra packet, extra encapsulation of whatever you have. So if you have your data here, these every single layer, right? Because they have their own encryption, they have their own way of like zipping things and stuff. So they add extra layers. So this will be like, let's say if this is layer 7, this will be layer 6, and all of them are actually important. All of these are important because they have information on how things are, making sure all the information is sparse, nothing is like tempered with and stuff like that. So things go like this, and this is, let's say, physical is your Ethernet cable. Let's say your actual copper wire or whatever you want to say, right? Let's say put the copper actual wire, which contains data. So like your copper wire. This copper wire connects to the copper wire of your friend's system, and things just like an onion, right? You know, you are peeling things. That same thing happens in this game now. All the information that was done, let me bring this. All this information, right? Now, as it passes to, let's say, layer 5, this layer. All people seems to need data transfer. That's a good one. Hi, Ruparkar. So layer 7, right? When you reach layer 7, layer 5, session layer is like, okay, I need data to make sure things are there, everything, nothing has gone. It rips apart this part. So it takes away this information and makes sure the data in layer 6 is good, right? Then we go to layer 6 after layer 5. We go to layer 6. Layer 6 says, hey, I want to check data in layer 7 hasn't changed. So it rip apart this layer 6 information, whatever is needed, and then this is gone. And like an onion, things get peeled, and what we get, the thing actually we want to eat at the very end. This thing, the data, what you sent, or like the email you sent on Internet Explorer, which was also sent from here, right? Oh, thank you, man. Thank you, Rover. Did I need to maybe even stop this one? But that's yeah, how it works. And let's go back to lead code to go over what every single layer is. But just to understand, things get put just like actually like when you are like pranking with your friend, right? You put a gift, whatever, like let's say an iPhone, in like multiple boxes, and then you take that apart, right? To unwrap it. We can use Cisco Packet Tracker. Yeah. Only 20 today. Yeah. Okay. So let's go to layer 1, physical layer. Let me know if I'm moving fast. It's just because I don't have much time in this week, so I'm trying to cover as much as possible. And these are basic, so we can still go fast. Yo, did you play some songs? I think some have. No, it's actually Rover who gave you what's this called, subscription. No. You don't have to restart, boss. On Twitch, he gave you the subscription, so that's the song was about. So going to layer 7, a big thanks to Rover, right? The physical layer, also referred to as layer 1, deals with the physical connection between devices. This device, or this includes the medium such as a wire and the definition of binary bits, zeros and ones. So the wires, the Ethernet cable, the copper cable, it doesn't contain like any big information, just because everything is just zeros and one in terms of volt, if you understand. But like it's just zeros and one traveling, right? The data transmission can be via an electrical, optical, or wireless signal. Let me show you guys something. This is the extender, right? This is the extender. And this is one of the ways people, this is like kind of, let's say you can say physical layer, because this is a for wireless signals. Data, when it reaches here, it's in zeros and ones always. Same with other wires like Ethernet and your optic wires, right? So all those contains data in zeros and ones. Consequently, we need data cables or antennas depending on your physical medium. Based on basically, yeah, if you are, let's say, talking to satellite, you need antennas through Starlink and all those, but there are still zeros and one. In addition to the Ethernet cable shown in the illustration below and the optical fiber cable, examples of the physical layer medium include the Wi-Fi radio bands, the 24 gigahertz band, the 5 gigahertz band, and 6 gigahertz band, right? Hopefully this makes sense. Optic fiber cable, everything is just zeros and one inside there. And let me tell you one more thing. This whole system is like Lego. Even if just one layer fails, irrespective of whichever, right? Any of them fails, the whole system is like a house, right? Even if one fails, the whole house is gone. Physical layer, if I cut the copper wire, things are gone. Just understand every single layer is equally important. The physical layer defines a medium to transmit our signal. The data link layer, that is layer 2, represents the protocol that enables data transfer between nodes on the same network segment. So, let's put it in simple terms. The data link layer describes an agreement between the different systems on the same network segment and how to communicate. A network segment refers to a group of networked devices using a shared medium or a channel for information transfer. For example, consider a company office with 10 computers connected to a network switch. That's a network segment. What this whole thing means is that after physical layer, after we have set up a wire between two computers, now they need to agree what language they want to speak, right? Essentially, if I want to, I'm like currently I'm talking to you guys in English because we can agree that you understand English, I understand English, we can communicate. There's an agreement. If I start speaking Japanese, half of you will start making fun of me or start bullying me. So that's, and not communicate basically, right? That's how things are. So basically enables data transfer between nodes. I don't know, some might know Japanese here, man. So in a company, you want computers to talk to each other, right? 10, all 10. They all 10 need to speak the same language. Or not only language, but also I can say just language. I don't want to use other terms. Example of layer 2 include Ethernet 8023, right? There is like various versions or let's say models. Wi-Fi 802.11. These are RFC, I think. Definition में IEEE, okay, for Ethernet. So examples of layer 2 are Ethernet, Wi-Fi. Ethernet and Wi-Fi addresses are 6 bytes. 1 byte is equal to 8 bits. So 8 zeros and ones. Like I don't know because everybody has different background. Let me bring this. This, let's say, is 1 byte. Everything is just, what is a byte is just a way of measuring how much data is inside. This is 1 kilometer, or sorry, this is 1 meter. Why? Because there are like 100 centimeters in 1 meter. What is 1 byte? This is 1 meter, has 100 centimeters. So this is 1 byte, has 8 bits. What is a bit? 1 bit is basically equal to 0 or 1. In the first layer we were talking about, right? So if you have 1, 2, 3, 4, 5, 6. Yeah. And because every single thing of this is a bit. This could be 0. Layer 2 remember MAC addresses and switches, and layer 3 remember routers. Yes, yes, yes. And I will tell you, layer 2 is very important too. You will start using it once you start building your own networking lab at home. So if you see here, this is, let's say, 1. All these are filled here, right? All these are filled. Now this all, so 8 bits, right? 8 bits make up 1 byte, and what they are saying is, in one chunk, or in, like, whenever Ethernet is sending things, is sending 6 bytes altogether, or the addresses are 6 bytes, sorry. So what does this mean? Like, okay, Wi-Fi and Ethernet addresses are 6 bytes, 6 bytes. So 6 bytes will be like 1 byte with all this information. Come on. So this zeros and bytes are inside here, all 8, 8, 8, 8, 8, 8, 6 of them, right? And they are paired in, I believe, two parts, right? Yeah, 2 parts. Why it is important to understand? Because this is like unique all around the world. Remember that. And I will tell you how things work. So their addresses are called MAC addresses. This address, how the MAC address is, you can imagine its name, a digital name given to it. Or actually, it's physically carved on it, actually. Their addresses is called a MAC address, where MAC stands for Media Access Control. You don't have to remember the name of MAC, like the full form, but just understand it's called MAC address. Also, if you have used iPhone, I think it's called Wi-Fi address on iPhone. They are usually expressed in hexadecimal format with a colon separating each 2 hexadecimal digits 1 byte. It's like your name, it doesn't change. Yes, yes. Or actually, like your name can change, like your IP address. This is more like your fingerprints or like your iris. This can't change. The 3 leftmost bytes identify the vendor. So this is how a byte looks. Wrong thing copied. One day I will learn properly how to do things. Fail to fetch the image. Okay, never mind. Okay. So what this means is that, like we talked about, like it's every single one of them is hexadecimal. What does that mean? Just like you have decimals 0 to 10, right? Those are decimals, DEC, DEC, that means 10, right? So 0 to 9, and then after 9 there is no other digit. So what we do, we put the first one, like if you, let me put it this way. When you are doing 0, 1, 2, yada 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 till 8 and 9, right? How the world works is basically this is 0, 0, think about it, is 0, 1, is 0, 2, is 0, 8, and 0, 9. Now after 9 we don't have a digit, right? What we do, we increase this next one. So now it becomes 1 0, 1 1, 1 2, yada yada yada, 1 8, 1 9. Now after 1 9, right, what we do, same thing. Replace the first one with 2 0, 2 1, 2 2, yada yada yada, 2 8, 2 9. And let's say if you after we reach 99, right, what we do, how last 9, right, became 1 0, right? So it will be 100. Again goes to 1, another, and it starts from 0. And it becomes 100, 101, right? So and if hopefully this helps you understand how actually maths work, point 1. Then let's say if after 9 we had, just like Shriram said, right? Imagine if we had, but I want you guys to understand this, why things are the way they are, bits, bytes, whatever. 8 and 9, right? Now let's, after 9, I don't want to use 10. I want something better. I want, like, at least instead of decimal, dec, I want hex, 16, right? 16 digits. So instead of 9, I will say it will be A, B, C, D, E, and F, right? So these are 10, 0 to 9 is 10, and then 6 more. So 16, right? And what is actually, if you think in decimal terms, value of F is 15, technically, right? But we introduced a new digit, A, B, C, D, E, F. And now after F, if I want something, how will I do it? Oh, nice, bro. And here it would be 1. Nice, bro. Nice, nice. Here it will be 1D, 1E, and 1F. You see how the game is? So when you see 2 hexadecimals, A4, now you understand what this means, right? A is some value, right? I think it's 11. Oh, sorry, 10. A is 10. 4, simple. All these things are actually put in. This is brought 1, I think. Hold up. And even every single one, like let's say it was A4, A4, C3, yada yada yada, till 2D, right? A4, if I want to represent 4 in bits, it is, right? And I think it's however things are, like there is more zeros. Same with A, I want to represent, and that's how zeros and all the bits come together. I think it might be a bit confusing in the start, but what I will say is try to break this A4C340 down into bits and bytes. Things will make a lot more sense how things are. But for a hacker or for a network person, right, what you need to understand that this is how a MAC address. Oh, awesome. Thanks, bro. So this is, now you need to understand, this is how a MAC address look, right? 6 how to say, bytes, with 6 bytes, yeah. So 6 bytes. Okay, there are 6 bytes, but what does these represent? The first 3, the red part, vendor who built the network interface. It is the interface, like for example Intel. It could be ARM. Let me bring my, I don't remember where it is, but let's say it could be Apple, right? Vendor, the company who created it could be Apple, could be Intel, could be ARM, could be, let's say, Nvidia, could be Samsung. Those names, the vendor, the person who created that thing. Next is the unique address of the network interface. Inside this vendor is a unique system. It's a unique what's it called? How do you say? Just like for example, in a company, right? First could be the company name. Second is the employee number, but instead of employee number, is the product number, right? That's and it's unique across the whole world, right? A company can have multiple, I believe, network interfaces because let's say a company like Apple would need more than a company like mine, right? Like Censored Hacker, which is a media company kind of a YouTube channel. I don't need much, so those are allocated to Apple. And this is like an employee number, the green one, which is like unique. And if you get a network chip, you can tell which company it is from. And if I do ARPANET on my system, should I do ARPANET? Fuck it. ARP. Okay, ARP-A. You guys can see this is the internet address, right? Or like the IP address. And this is the physical addresses. I don't want to show more. But you guys can play with this command and see what all devices with this IP, let's say you connect your phone and your computer, right? You do ARPANET and then see, okay, which address belongs to your phone. So that's a cool way to do it. Learn this thing, because if you're setting up in future, I want to set up a pure network lab or server in the back here. We will be using things like this to identify what IP address or what things belong to whom. Okay, now with that being said, let's move to, we expect to see 2 MAC addresses in each frame in real network communication over Ethernet or Wi-Fi. The packet is the screenshot below. A packet in the screenshot below shows the destination data link address, MAC address, highlighted in yellow. The source data link address, highlighted in blue. The remaining bits show the data being sent. So you see the yellow part, right? This is visible to you guys, hopefully. So this part, the yellow one, is all bits. If you see, MAC address is 6 bytes. 6 bytes. So 1, and it's 1 byte is 8 bits. So 1, 2, 3, 4, 5, 6. That's 1. This is for the source. Next is the destination. 1, 2, 3, 4, 5, 6. When you go home, let's see if I can copy this or open image in new tab. Yeah, let's do that. I will say this, an interesting activity for you guys. When you are able to like go home, find what zeros and ones converted into actual MAC address, right? It will help you. Trust me, this is like a stupid activity. Looks like a stupid, but it will help you. Take a screenshot or just go to this page. Try to convert this into actual MAC address. And you should be able to see if this, you see 44, DF or CC, 5E, these things, does they match exactly the same thing? This will help you understand things way better. And so that zeros and ones, which Wireshark is coming in future, it should not scare you. And the only way not to get scared of something is to face it, get it done. Okay? So that's layer 2 MAC addresses, which has like net devices or communication wires like Ethernet. Your Wi-Fi is a MAC thing, right? Your proper copper wire is layer 1. So layer 3, network layer. This is probably the last layer we will cover because we are almost out of time. But tomorrow I will come again. So I'm just going to come every day, even if it is for an hour. Okay. So layer 3, network layer. The data link layer focuses on sending data between 2 nodes. When they say nodes, 2 computers, 2 devices, whatever, right? The data link layer focuses on sending data between 2 nodes on the same network segment. 2 devices on the same network could be a network. Internet is also a network. So that's also included, right? It's a network segment. Doesn't mean like it cannot be big or small. It could be just inside my house. The network layer, that is layer 3, this is where IP address comes to play. Yes. So the network layer is concerned of sending data between TCP IP is layer 4 though. Yeah. Okay, yeah, but this will have that. Oh, thank you for following, mate. Thank you. I know this is just from follow music if you want to know. So the network layer, layer 3, is concerned with sending data between different networks. Sending data between different networks. I have to set up that command, man. I keep forgetting. Here is the Discord command. Okay. Sending data between two networks. Remember, sending data between two networks means is like when you are, let's say, sending a package, a parcel, a mail from one house to another. That's what we are talking about. If you're sending a mail from one house to another, one of the biggest things, or like on the packet, what you do, you put your address and the person you are sending it to and from. You put those two addresses like an email, right? So that's how things work. Yes, OSI model, mate. Yes. I can give you the link where we are talking about this from. We are working on PT1 certificate. Okay. So, address is on the envelope. Yes, yes, yes. I actually have a letter I will show you guys. So, I won't show my address exactly, but you guys should get the idea. The network layer handles logical addressing and routing, finding a path to transfer the network packets between the diverse networks. Finding a way to deliver your postcard, your mail from one house to another. Just like a postman, this layer is like the postman layer, right? Handles logic of addressing and routing. Postman or like the post company handles like, okay, how to reach here, right? Through a plane, through, let's say, trains, whatever. That's the game. In the data link layer, we gave an example of one company office with 10 computers, where the data link layer is responsible for providing a connection between them. Good morning, Panda. Let's say that this company has multiple offices. Oh, yeah, good morning to everyone. Let's say that this company has multiple offices distributed across various cities: New York, London, Delhi. Countries, continents, right? Covers all. The network layer is responsible for connecting different offices together. I am sitting in Canada. Panda is in Europe. You guys, Rover is on the other side of Canada. Shriram is in India. How things are working? Thank you to network layer. Jai Mata Di. The network below shows the computer A and B are connected. Although on different networks, you can also notice two paths connecting the two computers. The network layer will route the network packets through the path it deems better. What does that mean, right? Google Map. That means like a Google Map. There are, when you want to go to from one place to another, right? Let's see a good way. Okay, this is actually a better one. This is what you guys have seen the whole life, right? If you have used Google Maps or any other map, right? You are at point 1, right here, let's say. Can I copy this image? Oh, beautiful. I can copy here. Now let's talk about things are getting real, lads. So you are at point A, this one here. You want to go to, let's say, point B. This is not the best one. here. Okay, lads, give me 1 second, sorry. Okay. So you are here at point two. Sorry, my meeting, somebody joined, so I got the notification. So yeah, you are here, you want to reach here. Destination, right? These two addresses. Now there are multiple paths. Route 1, how much time will it will take? Route 2, how much time this will take? Route 3. So there are multiple routes, but the best one being this one with the least time. Our way of defining what is good and bad is based on time. If we had distance, it might be a different route, right? Based on what is the criteria, that's how we'll define. Yes, yes, I did. I did. Thank you. Where was I? Ivan will apply today. Thank you so much, boss. So, that's what they are talking about here. The network layer will route the network packets to the path it deems better, right? It thinks, okay, this path is better. Examples on network layer include IP protocol. IP, Internet Protocol, is basically one of the most important thing you need to understand here, right? In this, at least at the basics level. Why? What is Internet Protocol? Don't look at the word. Think it's or protocol or Internet Protocol. At the end of it is your address on the internet. Just like when you go, right? How IP address looks is this way: 10.10.123.99. This is how a IP address looks. You won't remember these numbers, right? A IP address is similar to having a phone number. Unique, right? Unique. Let's say my phone number is 255.123.123.4. Just like all the phone numbers are of 10 digits, IP address has like in 4 chunks these bits and bytes, right? This is how they look. Now, you don't remember the phone number of your friend, so you save it based on their name, right? In the phone directory. Same thing happens with the IP. You don't remember the Google's IP address and it can change, right? Your phone number can change. You ask the person every time new one, if they change. Same thing with IP address. These things can change. But you remember the name of the company or the URL, right? Google.com. So this basically is a name, a easy to remember version of this name, of this IP address, just like the name of your friend in the context is a easier way for you to remember their phone number. That's what IP is. Just an address on the internet where you can find the person or who to send to or who to look at, like the website and stuff. There is other protocols at this moment as well. ICMP. This is a way to just poke someone. I will say using ping. If you are like, oh, can I reach Google? This is the protocol you use. VPN, you might already know, right? A virtual private network, a special part to talk to someone, have a basically like a tunnel in the world of internet. When there are roads, you are going through a tunnel. Such as IPsec and SSL. So there are VPN also have like different type of protocols. So that was layer 3, lads. Sorry, I have to leave because it's 8. I have meeting. But I will come again tomorrow at 7. And for this week only, it will be just 1 hour. Next week, once I have more time, we will do like way longer ones. Okay? Oh, I got a message from somebody. So thank you so much. Awesome. Okay, lads. A big thanks to everyone of you, right, for coming. Do join the Discord for more chats and like fun stuff we do. and giveaways here. And I will see you guys tomorrow, right? Yeah, that's all for now, right? Till then, thank you so much. I will come in the evening for some lead code, and I'll see you guys in the evening with some interesting Python related lead code things I looked into and can be helpful in solving those problems. Till then, thank you so much. Have a good day. This is your sniffer of packets, your friendly neighborhood hacker, censored hacker, signing off with a big bye. Bye, everyone. Thank you.